We live in a world teeming with invisible waves of energy. Some of these waves bring us the music we love on the radio. Others carry the signals that allow us to connect with friends and family across vast distances. Among these unseen forces are microwaves, a type of electromagnetic radiation that has revolutionized the way we cook. Microwaves are a fascinating phenomenon. They are a form of light, just like the light we see with our eyes. But our eyes are not equipped to perceive them. They exist on a different part of the electromagnetic spectrum, a vast range of electromagnetic radiation that includes everything from radio waves to gamma rays. While we may not see microwaves, we can certainly appreciate their effects. These invisible waves have the ability to penetrate deep into substances, including food. This unique characteristic is what makes them so effective at heating our meals in a jiffy. The electromagnetic spectrum is a vast and wondrous thing. Imagine a piano keyboard stretching out infinitely in both directions. Each key on this cosmic keyboard represents a different type of electromagnetic radiation, defined by its wavelength. At one end we have radio waves with their long, lazy wavelengths. As we move along the keyboard, the wavelengths get shorter, and the energy levels rise. We encounter microwaves nestled between radio waves and infrared radiation. Their wavelengths are shorter than radio waves but longer than infrared. This places them in a sweet spot for interacting with water molecules. And as we all know, water is a key ingredient in most foods. The position of microwaves on the electromagnetic spectrum dictates their unique properties. Their relatively long wavelengths allow them to penetrate deeply into substances. At the same time, their energy levels are just right for exciting water molecules, leading to rapid heating. At the heart of every microwave oven lies a technological marvel known as the magnetron. This ingenious device is the engine that drives the entire microwave heating process. It's the maestro of the microwave orchestra, converting electricity into the invisible waves that heat our food. The magnetron is a relatively simple device in principle, yet its inner workings are a testament to human ingenuity. It consists of a vacuum tube containing a heated cathode, a cylindrical anode, and a powerful magnet. When electricity flows through the magnetron, it creates a stream of electrons that are whipped into a frenzy by the magnetic field. This frenetic dance of electrons generates the microwaves. These microwaves are then guided into the cooking chamber, where they work their magic on our food. Section 4. The dance of the water molecules, how microwaves generate heat. Water is the key to understanding how microwave ovens work. You see, water molecules are like tiny magnets with positive and negative ends. When microwaves penetrate food, they interact with these water molecules, causing them to rotate rapidly. Imagine a room full of dancers, swaying to a slow, gentle melody. Suddenly the music changes to a fast, upbeat tempo, and the dancers start spinning and twirling with increasing speed. This is akin to what happens to water molecules when they are bombarded by microwaves. This rapid rotation generates heat through friction. The more the water molecules vibrate, the hotter the food becomes. This is why foods high in water content, like soups and vegetables, tend to heat up much faster in the microwave than drier foods. Section 5. Debunking the myth microwaves don't cook from the inside out. There's a common misconception that microwaves cook food from the inside out. This simply isn't true. Microwaves penetrate the food from all sides, just like heat from a conventional oven. The confusion arises because microwaves can penetrate deeper into food than conventional heat. However, they still heat the outer layers first. The heat then gradually conducts inwards, just like in any other cooking method. So while microwaves offer the advantage of faster heating and greater penetration, they don't defy the basic laws of physics. Heat always flows from hotter areas to cooler areas, regardless of the source. Section 6. The quest for even heating battling microwave hotspots. One of the challenges of microwave cooking is achieving even heating. We've all experienced the frustration of biting into a seemingly cooked piece of food, only to find a cold spot lurking within. This uneven heating is due to a phenomenon known as hotspots. Hotspots occur because microwaves don't always distribute evenly throughout the cooking chamber. This can be influenced by a number of factors, including the shape and size of the food, the type of container used, and even the wattage of the microwave. Manufacturers have come up with various innovations to combat hotspots, such as rotating turntables and sophisticated waveguides. These features help to distribute the microwaves more evenly, but achieving perfectly uniform heating in a microwave can still be a bit of a culinary gamble. Section 7. Microwave safety, separating fact from fiction. Over the years, microwave ovens have been the subject of various safety concerns. Some of these concerns are valid, while others are rooted in misinformation and fear-mongering. Let's delve into the science behind microwave safety and separate fact from fiction. One of the most persistent myths is that microwaves can cause cancer. This fear stems from the misconception that microwaves are a form of ionizing radiation, the kind that can damage DNA and increase cancer risk. However, microwaves are a form of non-ionizing radiation, which simply means they don't have enough energy to break chemical bonds or alter DNA. While microwaves themselves don't pose a cancer risk, there are other safety considerations to keep in mind.